is your own command.
Yeah,
Yeah. No, it is. It is.
I know it is.
Yeah. All right. Okay. So actually, I don't need this anymore. Right. So we're having a look at inverse now. Don't need all these windows open either. Okay. So can we see? Okay. Do you want to move that a bit to the left, second? Keep going. Keep going. Keep going. What? Oh. Yeah. Oh, nice. Maybe a little more to the left. Just a little. Yeah. Satisfying. Me gusta. Right. Inverse functions. What does the word inverse mean here? What do we mean by inverse? When we say inverse of something.
Something reverse.
Like reverse. Yeah. So you have this idea that if you have a function f of x, let's say for example it's 2x. So what would be f of 4? It would become 8, right? We want to find a function that would let you go backwards. That is, if you calculate the 8th, your answer should be 4. So in this case, what function would let you go backwards?
X.
No.
Or minus 1.
No.
X divides 2. Yeah. So like for example, if I calculate f of 4 using this formula, what will I get as my answer?
8.
It'll be 8. And if I calculate f inverse, that's the name of this function, of 8 using this formula, what do I get? 4. So this symbol here with the little minus 1, we call that the inverse function. It's the function you need to do the reverse of the f. Reverse slash.
But you have to give us the function?
Yes. So you'll be given a function and you want to find the inverse function, the function that will let you go backwards. Okay. So sometimes it's easy. Like for example, if I said the function is x cubed, what is the inverse function? What is the function that will undo this cubing action? Cube rooting. Yeah.
Yep.
So sometimes it's pretty obvious what the inverse function is. Sometimes it's not. Okay, can I go down?
Yes.
How can we find the inverse function when it's a little bit more difficult? So for example, suppose I have a function like this. Suppose I have a function where you take x, multiply by 2 plus 4, and then divide it by 3. So what would, for example, f of, I don't know, let's say 4, 8, f of 4. What would that be? Calculate that, please. In this case, it would be 4. Okay, and what about f of 0, for example?
4 over 3.
4 over 3. And so on. So what's the inverse function here? Well, it's not as obvious. What do you think?
3x minus 4 over 2.
3x minus 4 over 2. Tis. Now, one way you can find it is by using these kind of set diagrams. So for example, if you think about the x as your starting point, what's the first thing you do to x? You multiply it by 2. So it becomes 2x. And then what's the next thing you do to the x?
4.
You add 4 to it.
Yeah.
And then what's the last thing you do to the x?
Divide by 3.
Yeah. You divide your answer, by 3. So you can kind of go backwards. So imagine you start with x. The last thing you did was dividing by 3. So in the inverse function, that is the first thing you do, but it's a reverse. So yes, so what you do is you would multiply by 3. Here, what did we do? We added 4. So here, we minus 4. And here, the first thing we did was multiply by 2. Therefore, the last thing we should do, divide by 2. So this kind of bubble diagram can let you make the inverse function. So we need to check that it works. I'm claiming that the inverse function is 3x minus 4. So if I, and you too, if I calculate the inverse of 4 over 3, what answer should I get? It should bring me back to 0. Yeah? Because 0 became 4 over 3, so the inverse function should take 4 over 3 to 0. So let's calculate the inverse. It's 3 times 4 over 3 minus 4 over 2. 3 cancels 3. 4 minus 4? 0. So yes, we do get 0. So this is the inverse function. Yeah? Yes? Okay. Can we always find an inverse function? What do you think?
If it's a solution, then yes.
Right, so I want you to try and do this one for me. F of x, and you can use the bubble diagrams. F of x equals x squared plus 1.
Square root of x minus 1. Yep.
Yeah?
Yeah.
You clean fast.
Yeah? Do you think so?
Yes.
Do you think so? Do you really think so?
Yeah.
What if I was to tell you were wrong?
Wait, let me think again.
So you have to use diagram?
Diagram's good.
No, no wrong.
You sure?
Wait. Yes,
No, it's
because there's nothing like square root of minus 1.
Yeah, this function does not have an inverse.
Yeah.
Why does it not? Because it thinks it should, right? If I start at x, what's the first thing to do? What's the first thing to do? Square it. And then what's the last thing to do? Plus 1. So in the inverse process, what's the first thing to do? And the last thing to do? So let's test it. What's f? I'll just do it on the side here, correct? What's f of minus 2?
4, 5.
5. So what should f inverse of 5 be?
Minus 2.
Minus 2. Let's see what we have. So here we have square root 5 minus 1, square root 4, which is 2.
But no minus.
But no minus.
Plus or minus.
No, because then that is now a 1 to many. We're only talking about 1 to 1 functions here. So anyways, this gives us, it brings up the next issue, which is functions only have an inverse, so you can only find f inverse exists if and only if f is onto. Now do you remember what onto means?
Yes.
Do you?
Yes.
Okay, it's like.
Oh, sorry, not onto. That's the wrong word. Only if it is 1 to 1. And also, it should be onto as well. Although, that's not, it's much more important that it's 1 to 1. If it's not onto, it's very easy to fix it, to have it inverse. But you can't fix it if it's not 1 to 1. 1 to 1 is a much more serious problem. So x squared isn't really a function that has an inverse, because once you square a negative, it's impossible to go back to it, because you can never know if it was originally positive or negative. It's the 1 to 1 is the only way to know the correct original x from the answer. Okay? So x squared is not really a function which has an inverse. What about x cubed?
No, no, it doesn't. Not
Well,
necessarily.
kinda.
But
Sometimes it does, and sometimes it doesn't.
yeah.
So x cubed by itself, what do you think? It
Yeah.
does. But not all cubic functions are one to one.
Yeah.
Some of them are many to one. So it means they use one sometimes an inverse. But before we go on to more complicated details, I want to show you a second way to find an inverse, which maybe most people prefer to do. So we'll take something like fx equals 2e 3x plus 1.
Plus one.
Yeah, it should be a plus 1. Right, so you can actually do it the way I showed you. It works just fine. What's the first thing you do here
What
with the x? If you were doing the bubble diagrams, what's the first thing?
What log?
Is there a log here?
No.
Times 3.
Times 3. Second,
Plus 1.
Plus one.
next,
E.
and finally,
Multiplied by 2.
multiply by 2. So if you were going backwards, what would be the first thing you do? Divide by 2. And the next thing you do,
Log.
log it.
Wait.
Yeah?
Uh,
And then the
minus 1.
next thing you do is minus 1, it. And the last thing you do is divide it by
3.
3. So that would be the inverse function. But some people don't like that. There is another way to do it. So I'll do it the other way as well. K to the J. I can see you typing there. I see you have some instant message opening. I see bubbles on the screen. You're chatting to someone. Hey, it's KJ here. What did you think of Arrow last night? Wasn't it totally maze? Oh yeah, best episode ever. Something like this? Alright. Can I show it
Maybe
the
you
other way?
always talk about you in your class.
You might be. You might be saying, oh, I'm in Stephen's class now. Totally lame. He's boring. You want to get coffee later? Sure. Frappuccinos all around. This? No?
No. No.
Not like maybe a
Yeah.
similar.
Not this. Just no frappuccinos. The rest is true.
Yeah.
Alright. I can show you the second way.
Yeah.
Yep. Is there something going on this evening? Is there a social outing or something? Or was that last week? The Wax Museum.
Yeah, no.
Yeah.
Did you go to it?
No.
No.
No one here went to it.
No.
I told Sylvia some of my engineers might go.
Nah.
No.
Wax. No, wax.
Like museums, not even cars museum. Wow.
Alright. So, the
I
other...
was going to the Mercedes show maybe. No.
Exactly.
Yeah,
Yeah.
I'll try to arrange that then.
Arrange what?
I can sure about Mercedes or BMW. I was going to.
Yeah.
If they give us a free ride.
That's right. Yeah, well, I
Exactly, test drive.
Yeah.
Movies.
Yeah. I don't see that ever happening. The other way to do it is, you make this equal to y, is the first step.
I know this.
You know this way?
Yes.
Yeah. And then you solve for x.
Yeah.
So we imagine we're solving for x. So we
So X-
divide by 2. And then what would be next?
Log.
You log it.
Cancel.
And then that will cancel that. So you have y over 2 equals 3x plus 1.
Where's log?
Yeah, sorry, I didn't write it in yet. Log y over 2 equals 3x plus 1.
Yeah.
Log y over 2 minus 1 divided by 3
Close.
equals x. So step 2 is solving. And then step 3, once you've solved it, your answer is this piece here, but the x is just replaced by a y, the y is just replaced by an x. Now, I have this issue with the people who write the exam, because we disagree on something. Because I told them that it is perfectly fine to write this as the answer. That should be an x there. That if you didn't change the y to an x, if you kept your answer like this, see here?
Yeah.
But just made sure you wrote here f inverse of y, that's perfectly legitimate.
Yeah.
So if, at the first, why you make it y? Make it x.
Here?
At the first step.
Oh yeah, that's fine. Like some people, they like to swap the x and the y at the start. So they would write x equals 2e 3 log y plus 1 and then solve this for y.
Oh.
Some people do that.
But we.
Or, equivalently, you can just do the swapping at the end. So you see here, when we go from here to here, the last step is to swap x and y. So it gives you this as the answer. Now, what my point is if you didn't swap the x and y and wrote the answer like this with a y in it, with a y here instead of an x and an x, that's exactly the same. Like, there's no difference. Because, for example, if I tell you fx equals x squared, what does this function do? It squares a number. It squares the input. What does this function do? And this function? Yeah, so these are all the same function. The letter is not even important. It just the letter is used to define what the function does, but it doesn't have any importance. So I told my students they could write the answer like this if they don't want to bother swapping the x and the y at the end. And the people who write the exam said this is not acceptable, but it is. It's just they don't know that it is. This is the problem. So look, I'm telling you that you need to make the swap at the end, but you only need to make the swap because the examiner in the UK wants to see the swap. But I'm telling you now, mathematically, there's no need to. Okay? Right, so that's the second way to do it.
This is only if there's e.
No, you can, anyone. I'm just showing you two different ways.
That's how you do it.
Yeah, this way is the way all the students do it. They prefer to do it like this, where they have to solve an equation. Yeah, that's how you learned it.
Yep.
That's how you learned it.
Yeah.
It's the usual way.
Even this thing I was saying the day before yesterday.
This is what you were talking about, was it? Okay, yeah. Have you seen have you done with the set notation before? Have you ever seen it done that way?
The diagram?
With the diagrams. You've seen it that way?
Yeah.
You have seen it that way? Yeah. Okay.
I mean,
So, some things never change. Right. Now, earlier we were talking about when functions have an inverse and not, so we need to focus on that a bit more. So, what we really need, technically we need our function needs to be 1-to-1 and onto. Now, do you remember what the definition is for onto? Yeah,
The
actually.
range equal to the domain.
You have it half right. Yeah, the range needs to equal something. Yeah. So that's onto. The range must equal all real numbers.
yeah.
And 1-to-1. Well, 1-to-1, do you remember, is if the x's are different, then the y's should be different as well. Now, the onto condition, if it's not satisfied, it's easily satisfied. Let me show you. Can I go down?
Yes.
Yeah. let me give you a very good example. So suppose I say fx equals e power x. Is this function one-to-one?
Yes.
Hello? Anybody home?
Yes.
Is this function one-to-one? It is. Is it onto?
Yes. No.
How do you know that it's 1 to 1 now?
The graph, I know it's one-to-one because of the graph. Do you remember? Because it only meets once horizontally and it only meets once vertically, is a one-to-one graph function. Do you remember? So this makes it 1, 2, 1. 1, 1. Anyways, is it onto? We know it's one-to-one. Definitely one-to-one. Is it onto?
Yes.
No.
No.
Because, why not?
Because not all real numbers.
You don't get all real numbers in the range, do you?
No.
This takes a real number in the domain, and then the codomain, which is all real numbers. But the range, does the range fill up this set? No, the range only fills up half of it about, so to speak. It only fills up the positive numbers. The range is just the positive numbers. So it's not onto because the range doesn't fill up all real numbers. You only get half of them, only the positives. Okay? But the way you fix that, and it's very, very easy to fix, is you just say f is a function that takes a real number and then it returns a positive number. Now it is onto. Because what you've done is, it's almost a bit like cheating. What you've done is you've just said, this function takes a real number and the codomain is the positive numbers. Like, when you write it like this, you're specifying that the codomain is only all the positive numbers. So, what I'm saying is, if a function is not onto because it doesn't fill up the codomain, all you have to do is change what the codomain is, which you're allowed to do actually, because you say what the domain is, you know, what values of x you're allowed to use. So likewise you can say what's the space the function goes into. This isn't really the part I want to focus on. It's the when it's not one-to-one is the problem one. This is really the problem one. By the way, what is the inverse function here?
Linear.
Yeah. Now, can you use any number here?
No.
No, you can only use positive numbers, and you can get a real number as the answer. So this log x, notice how the log x's domain, you see here, is the range of the previous function. Which makes sense if you think about it. The f goes from here into the range, which is positive numbers. So the f inverse, the log x, should go from the positive numbers back. So the fact that this is the opposite of this is actually, that's what it should be. Okay? But now the more serious problem is, what if it's not one-to-one? So for example, if I said f is a function that goes from the real numbers to the real numbers, and f of x is, let's make it a quadratic. I don't know, something like this. Is this function one-to-one? So what I'll do, we'll make it a small question. So the first one is this function one-to-one? Is it onto? And then the second one is, well, we'll get to that first. So the first two, I'll give you a minute to try it. Is this one-to-one? Now, if you're saying it's not one-to-one, it's not. If you're saying it's not one-to-one, you need to prove it. And the way you prove it's not one-to-one is you need to find two values of x that make the same y value. Once you've done that, the proof is finished. Yeah? So I'll give you a moment to try that. What's wrong? No? What? You look confused.
Because the quadratic thing is
Yeah. So we all agree it's not one-to-one. We're agreed? Agreed. So you need to prove that it's not. So you could say because the shape of the quadratic, but it's much better if you can show with a number value. Clearly, it's not one-to-one. Have we done this, KJ?
what?
Oh my goodness.
Remove it and
This is a habit, is it? It was back in high school. He's talking about functions. Karaya, I want you to show that it's one-to-one, so I need you to find two values of x that are different.
I need to get the turning point.
That is one way to do it, yes, for sure.
Turning point.
My goodness, KJ, are you trying to annoy me? That's what Karaya asked me 30 seconds ago.
When you get to listen to me.
To listen up, KJ.
Scales up.
What?
Kim said that to you.
Okay. Have we got the A part done?
Yeah.
Alright, so A part. Here's part A. Fx equals x squared plus, what did I say? 3x plus 2. Is this one-to-one? No. It's not 1-to-1. Why not?
Because there's two values that can go.
Yeah, and what are those two values?
Plus x equal to minus 2, x equal to minus 1.
Yeah. There's many answers here. So f of minus 1 equals 0 and f of minus 2 equals 0.
Yeah.
That's one example. Does anyone have a different one?
So 1 and minus 1?
Yeah. No? Did you find the turning point, Karar?
Yeah, but I didn't take it.
Okay.
Turning point.
Alright, so is that okay for A?
Yeah.
Now for B, is this function onto?
No.
No. You don't get all the numbers. What numbers do you get now? So tell me what the range is, I think is. Yeah, is it onto? So it's not, because if you look at the range, it's not all the real numbers. So tell me now what the range is. I want you to get the range. And again, Karar, you could use a turning point to get the answer. That's one way to do it. From the graph. If you like, that's only one way to do it. What you get? Go on.
I don't want to see you.
No, tell me. I won't look at you. What did you get?
The number is the minus 2 minus 1.
Tough break, man. That's not it. That's not it. Anyone else get the range?
No.
No. Can you get the turning point?
Minus
No.
3 or 2.
Karar, can you find the turning point?
Yes, 1 minus 1.
That's the turning point.
Yeah.
Yeah. So what's the problem? Your turning point is you got 1 minus 1.
Okay.
Yeah? So the graph looks like this, doesn't it? Yeah?
Okay.
What's the turning point. You still with me, right? Yeah?
Yeah.
So the range is all the y values. So it'll be all these numbers from -1 up to infinity. That's the lowest point. Right? What is the range? The range is all the y values. All the values you can get, all the answers, right? So that's one way to do it, but I prefer to do it by completing the square. Have a look. You can say that this is, and are you sure it's 1 minus 1 as well? I don't think that was right for the turning point.
I don't think so.
No, sorry, bad luck. I don't think that was the turning point, correct?
-3 over 2 and
Yes,
minus
yeah,
1
yeah.
over 4.
Yes. When you complete the square, you get x plus 3 over 2 squared. That'll be 9 over 4 minus 1 over 4. Did you say it was minus 1 over 4? Yeah. That's the completed square. What's the smallest this can be? And don't screw it up like last time.
-1/4?
Yes. Thank goodness for that. So the smallest this can be is -1 over 4. See, we're learning.
Yeah, because that number is the smallest we can get. Just say
Yes.
the number.
Yes, yes. So the range
Don't have to confuse it.
The range is all numbers from -1 over 4 to infinity is the range. So you can see that this means it is not onto.
Oh, we have a big chart about this. Long chart, yeah.
Too long.
Too long.
Okay, so before I go on, let's draw a very quick graph of what we have. So our graph looks like this. You know those two values we used at the start? -1 and -2, they're the roots.
Yeah.
So you have -1, -1, I'll space that a bit more, -1, -2. Where was our turning point? You found it, KJ. It was -1.5.
-1 over 4.
Yeah, so this here is -1 over 4, and this number here is -1.5, and these are the roots. So the graph looks like this.
Yeah.
Now, it's not 1 to 1. If you look up, look, it is many to 1. It's not 1 to 1, it's many to 1. So for example, f of -2 and f of -1, what's the answer? 0. And then if you put this number into the calculator and you get an answer, and you put this number into the calculator, you'll get the same answer. So for this, it's not 1 to 1. You can get the same answer twice. So the next question is, could you find a domain that makes it 1 to 1? In other words, can you restrict what values of x to use so that the function is now 1 to 1? Let me give you an example. X squared is not 1 to 1. Why not? Yeah, so give me an example. -1 becomes 1, and 1 becomes 1. So it's not 1 to 1. But if I said only use positive numbers, what's 1 squared? 1. 2 squared? 4. What's the square root of 1 and 4? 1 and 2. And you know that must be the answer because the domain is only positive numbers. The function is only being used on the positive numbers, so you know that when you square root it, the positive number is the correct answer. So that's what I mean. Can we restrict the domain so that the function is now 1 to 1? That we don't have any uncertainty about what was the original x? What do you think?
Okay, maybe it would be nothing more than -1.5.
Correct, that's one way. So what you could do is, imagine I told you you could only use values of x from -1.5 to minus infinity.
Yeah.
Now the function is 1 to 1 because when I draw my horizontal line, this part is gone because I have to stop here. So it crosses horizontally once, and vertically, how often does it cross?
One.
Again, just once. So now it is 1 to 1. So by cutting away half of the graph, you can make it 1 to 1. But of course you realise there was another way to do it as well. You could have said only use values of x which are bigger than minus 1.5. Now, again, the function has become 1 to 1. Because you can't use minus 2. You could calculate f of minus 1, what do we get? 0. Do we ever get 0 again? No, because the only way to do that is to calculate f of minus 2, which is now forbidden if I'm only to use these values. So the answer back here, sorry, I'll go down here. Where do I want to write it? Right here. The answer for part C is you could use a domain like minus 3 over 2 to infinity. Yeah?
Thanks, Steve.
Oh. Do you get what I'm saying here? That by choosing the right domain, you can make it 1 to 1. And by choosing the right codomain, you can make it onto. What should be the codomain here? Well, you want the codomain to be the same as the range, so we should make the codomain equal to the range. So what was the range?
Minus 4 to infinity.
So now we have
Like 1 over 4.
like this.
Yeah.
Yeah.
So now this function f, which goes from a domain of minus 3 over 2 to infinity, and a codomain of minus 1 over 4 infinity, and the function is defined as x goes to, what was it, x squared plus 3x plus 2. This function is now 1 to 1 and onto. So the last question here for this is to find the inverse function. So I want you to do that for me. Get the inverse of this function. It now is invertible. It now has an inverse because it is both 1 to 1 and onto. Oh, by the way, notice how there's multiple answers here because I could have thrown away a different part of the graph.
Yes.
Do you get an inverse? Impossible.
Yeah.
So you were just watching us.
I really thought someone could get it. It's like, there is an inverse.
But it will be something.
Something.
Okay.
You know, if I had, it will be something actually. Let me see the book. I'll make sure I've covered everything you need. Oh, yes.
It will be an x and a 2.
No, let's have a look at it. Okay. No. You had your chance. You failed.
Oh.
I'm done.
What's the answer?
Chill out. X minus 1.
Yeah? Oh, wow. No.
Yeah,
That's
x minus 1.
Just give me 1 minute.
Yeah, because
1
the
minute.
other x minus 2 would be...
No. Stop it right there. No, I'm doing it. Right. So we'll use the method I showed you today. Y equals x squared plus 3x plus 2. Yes? What do we do next, do you think?
Minus 2y minus 2.
No?
Up to right.
No?
We'll take the square of.
No? No? Complete the square. Dude, complete the square. Complete the square.
Oh, okay.
Yeah? So that's x plus 3 over 2 squared minus a quarter. That's y plus a quarter equals x plus 3 over 2 squared. See where I'm going with this? Square root both sides. We are using the positive right side, so I don't need to worry about the negative. So you get here minus 3 over 2 plus root y plus 1 over 4. What does that equal? X.
Okay, I got it.
You bet it.
So the square root gets done with what?
Square root on both sides.
To this side,
Yeah, there was a square root here that cancelled this, and the square root here. So f inverse x equals minus 3 over 2 plus root x plus a quarter. That is now the inverse function. So the last thing, I think was some other thing just to show you. Oh yeah.
You shot it.
Doing some maths in here. Right, there's
Gossip.
two things left to show you here. So, can I continue, please? Yeah. No, no. Look at the time. I want to get this finished now. So focus here. F. One feature of inverse functions is that if you compose the function with the inverse of the function,
Yes.
you always get a cancellation and you're left with x. Let me give you a quick example on the side here. If f of x equals ex, what's the inverse here? Log x. So if you calculate f inverse of x, that's f of f inverse, which is log x, and then f is e log x, and what happens here?
X.
Cancel. Yeah. So look, all I'm saying is sometimes in the exam, they might ask you to check this cancellation happens.
You want us to check it out?
No, there's not the time, but I want you to know that this is a result which should always be true. If this is not true, it means your inverse is wrong. And the last thing to do is to graph the inverse function. Yeah. But there's a quick trick I want to show you to graphing it.
Okay.
So can I go down?
Yes.
The trick is, if you have the inverse function, like let me try and draw it a bit. It was a bit to the left, wasn't it? Now, actually, I don't include the whole thing, but I'm just drawing it. I was just doing the piece on the right. It doesn't matter right now. Yeah. Now, it's very difficult to imagine this. I think I had a video up on YouTube. Well, what you do is you draw a 45-degree line through the origin, and as best you can, you imagine that this graph is on glass, and flip it around the 45 line. No. Just do what I say. This isn't idea time, listening time. So, you draw a 45-degree line, and you flip the graph around this line. So if we can use our best imagination. Hold on, I can do this.
Something.
What?
Sort of.
That's not the mirror shape.
But look, this is why I got the graph program. So what was the function? X squared plus 3x plus 2. So I'll graph this. Okay, and then what was my inverse function? Right second.
3 minus 3 over 2.
Minus 3 over 2.
Yeah.
Square root of
Plus square root of
x.
Yeah.
Plus 1 over 4.
Like this?
Yes.
Like this?
Yes.
Alright, let's graph it. Now hang on, I'll put in the minus one as well. Oh, sorry, my graph, yeah. So can you imagine there's a 45-degree line going along here?
Okay, like transformation.
Yeah, it's flipped around it.
Transformation is said mirror shape.
No, I didn't.
No, he said.
I never said mirror. I said flipped around. Yeah, flipped around the 45-degree line. That's, oh goodness. Imagine there's a line going along here.
Yeah.
We flip it around this line.
Oh, okay.
Now, we'll talk about...
Imagination.
Yes, imagination is difficult. We will do many of these in tutorial, I think, next week. I think will be good practice, okay? So,
Can you go on to the site?
yes, but we need to get out of here.
Just a minute.
Yeah, yes.
Assignments.
Figure it out. Just, you know yourself. Pick some questions
No,
from
no,
each
no,
to
no.
practice. Where?
This is
The graph.
No,